Hello everyone. In this video, I want to talk about maximum likelihood estimation or MLE, which is an important concept for machine learning, and several machine learning algorithms have been developed based on maximum likelihood estimation. In maximum likelihood estimation, we have two important components. The first one is an observation, and the second one is unknown parameters. And our goal is to find the parameters such that the probability of the observation is maximized. So in this video, I denote the unknown parameters by theta, and I provide two numerical examples to understand this concept better. In the first example, we want to consider a coin that the probability of observing head is unknown and is theta. So because the probability of head is equal to theta, we know that the probability of observing tail is 1 minus theta. And we flip the coin 6 times and we observe this sequence. So we observe head, head, tail, head, head, and the last one is tail. So this sequence is our observation, and probability of observing head is our unknown parameter. So based on maximum likelihood estimation, we should find theta such that the probability of this observation is maximized. So the probability of this observation, we denote this probability by L of theta, would be equal to theta, probability of observing head, times theta, probability of observing head, times probability of observing tail, which is 1 minus theta, times probability of observing head, which is theta, times probability of observing head, again it is theta, and multiply by probability of observing tail, which is 1 minus theta. And this probability at the end would be equal to theta to the power 4 times 1 minus theta to the power 2. So this function L of theta is called likelihood function. So this is our likelihood function. And our goal is to find theta such that the likelihood function is maximized. So if we want to find theta, we should find a theta that maximize L of theta, which is equal to theta to the power 4 times 1 minus theta to the power 2. And also remember that in this example, theta is between 0 and 1. From calculus, we know that if we want to maximize a function, we can find the derivative and set the derivative equal to 0. So I'll do that. So I calculate the derivative of likelihood function, which is equal to 4 times theta to the power 3 times 1 minus theta to the power 2 minus 2 times 1 minus theta times theta to the power 4, and we set this equal to 0. So in order we have 0 derivative, we can have theta equal to 1, we can have theta equal to 0, or just we can have 1 minus theta times 4 minus 2 times theta equal to 0. And the reason is that we can rewrite this derivative in this form. So we can write theta to the power 3 times 1 minus theta times 4 times 1 minus theta minus 2 times theta. So if we want to have derivative equal to 0, theta should be 0, or 1 minus theta should be 0, or this term should be 0. And this, if the last term is equal to 0, it means that theta is equal to 2 over 3. So just if we look at the likelihood function carefully, we can see that at theta equal to 1 and at theta equal to 0, actually the likelihood function is equal to 0. Therefore, these two, theta here, theta equal to 1 and theta equal to 0, cannot be the maximizer of the likelihood function. And theta equal to 2 over 3 is the maximizer of likelihood function, and this is our maximum likelihood estimate. Okay, so I also have prepared another example. Is a little bit more complicated, but I think it's worth to try it and see how maximum likelihood estimation works. So in the second example, we have a die. So if we roll a die, the probability that we observe 1 is equal to theta 1. Probability that we observe 2 is equal to theta 2. And probability that we observe number 3 is theta 3. And probability that we observe 4 is theta 4. probability that we observe 5 is equal to theta 5, and probability that we observe 6 is equal to 1 minus theta 1 minus theta 2 minus theta 3 minus theta 4 and minus theta 5. Just here I did not introduce a new unknown parameter theta 6 because we know that theta 6 can be written as a function of theta 1, theta 2, theta 3, theta 4, and theta 5. Okay, and now I roll a die for 10 times and I observe this sequence. So I observe 1, 1, then I observe 2, then I observe 1, then I observe 3, I observe 6, 5, 6, I observe 4, and lastly I observe 1 again. So given this observation, we want to find parameter theta 1, theta 2, theta 3, theta 4, and theta 5 such that the probability of this observation is maximized. So how can I find the probability of this observation given our parameters? So just remember that the unknown parameter theta here is a vector of theta 1, theta 2, theta 3, theta 4, and theta 5. So the observation, the probability of this observation is equal to theta 1 times theta 1 times theta 2 times theta 1 times theta 3 times theta 6 times theta 5 times theta 6 times theta 4 and times theta 1. And remember that here I did not define theta 6, so instead of theta 6 I write 1 minus theta 1 minus theta 2 minus theta 3 minus theta 4 and minus theta 5. And same here, I write 1 minus theta 1 minus theta 2 minus theta 3 minus theta 4 and minus theta 5. And if I simplify this Lockwood function, I can see that this would be equal to theta 1 to the power 4 theta 2 times theta 3 times theta 4 times theta 5 and times 1 minus theta 1 minus theta 2 minus theta 3 minus theta 4 minus theta 5 to the power 2. Okay, and now we want to find the unknown parameter such that the likelihood function is maximized. So sometimes it's easier to work with the log of the likelihood function instead of the likelihood function itself. So here our goal is to find the maximizer of likelihood function, but sometimes it's easier to maximize the log of likelihood function. So because log is an increasing function, it is the same to maximize L of theta or maximize log of L of theta. So the maximizer of L of theta and the maximizer of log of L of theta would be the same. So log of L of theta is called log likelihood function, and just we denote this function by capital L of theta. In this example, log likelihood would be equal to 4 times log of theta 1 plus log of theta 2 plus log of theta 3 plus log of theta 5 sorry log of theta 4 plus log of theta 5 plus 2 times log of 1 minus theta 1 1 minus theta 1 minus theta 2 minus theta 3 minus theta 4 and minus theta 5. Now I find the derivative, but remember that here we have 5 different variables, so we should calculate the derivative with respect to these 5 variables, and then we should set the derivative equal to 0. So derivative of L of theta with respect to theta 1 would be 4 over theta 1 minus 2 over 1 minus theta 1 minus theta 2 minus theta 3 minus theta 4 and minus theta 5, and we should set this equal to 0, and we do the same thing for other variables. And if I continue this, you can see that we get the same we get a similar formula for derivative with respect to theta 4 and with respect to theta 5. Okay, now just by comparing these 5 equations, we can see that actually theta 2 should be equal to theta 3, should be equal to theta 4, and should be equal to theta 5. And these variables should be equal to theta 1 over 4. Because as you can see, this term is the same in all the derivatives. So therefore, just by comparing these equations, we can see that theta 2 should be equal to theta 3, should be equal to theta 4, and should be equal to theta 5. And these variables should be equal to theta 1 over 4. So now it's very easy to find theta 1. Okay, now I write the first equation one more time here. So for the first equation, we had derivative of L with respect to theta 1, which is equal to 4 over theta 1 minus 2 over 1 minus theta 1 minus theta 2 minus theta 3 minus theta 4 and minus theta 5. And we should set this equal to 0. And remember that here theta 2 is equal to theta 1 over 4. This one is equal to theta 1 over 4. Theta 4 also is equal to theta 1 over 4. And theta 5 also is equal to theta 1 over 4. And if we simplify this equation, we will get 4 over theta 1 should be equal to 2 over 1 minus 2 times theta 1. And this will give us theta 1 equal to 4 over 10. And remember that theta 2 was equal to theta 3, was equal to theta 4, and was equal to theta 5, and was equal to theta 1 over 4, which is 1 over 10. And also from here, we know that probability of observing 6 should be also 1 minus theta 1 minus theta 2 minus theta 3 minus theta 4 and minus theta 5, which is equal to 2 over 10. Okay, as you can see, maximum likelihood estimation is a very simple concept, and it can help us to estimate some unobserved parameters based on the observation. In the next video, we want to see how this concept can be used to develop some machine learning algorithms. For example, we will talk about logistic regression, which is based on maximum likelihood estimation. Thank you, and I'll see you in the next video.